Okay, this is the P2 paper from June 2023. It's question number 4, and as we can see by looking at this, it's a binomial expansion question. Let's have a look and see what they've got. We've got expand 3 plus px all to the power 5, and if we do that, they're telling us that first 4 terms are given by a plus bx plus cx squared plus dx cubed, and then we've got to find, well, first of all, we've got to find the value of a, and then we've got to find P and C. But let's concentrate on A first of all. So, part A, we have 3 plus Px all to the power of 5. So I'm going to use the fact that A plus B to the n is equal to, and now I say this every time I do one of these questions, I know this formula. I might be writing it out, but I know it and I know how to generate it. I've not looked at the formula booklet for this. It's an, and then it's nc1, take 1 off the power of a, have 1 of the power of b, nc2, take another 1 off the power of a, add 1 onto the power of b, and so on and so on and so on when we're going through and doing it. So I can now apply that to 3 plus px to the 5 using exactly the same idea. So it's a to the n, which is 3 to the 5, is then going to be 5c1, 3 with 1 off of the powers and a px on there. It's going to be 5c2, 1 less for the 3's and 1 more for the p's, and so on and so on and so on. Where do I need to go? I need to go up to x cubed, don't I? So it's the last term here. 5c3, 3 squared px cubed is equal to, now normally I would actually go and write all that out, but we're only looking at each individual bit, so we'll do each individual bit separately. What I will always do is, before I go any further, just check and make sure, if I look at the 3's, for example, 3 to the 5, 3 to the 4, 3 to the 3, 3 to the 2, yep, no copying errors there. I've got 5c1, 5c2, 5c3, and going on. They're in a nice pattern. I've got 3 to the 4 and p to the 1, they add up to be equal to 5. 3 to the 3 and p to the 2, they add up to equal to 5. And finally, they add up to be equal to 5 as well. So I'm quite happy that that seems to be okay with me. Remember then, we're saying this is a plus bx plus cx squared plus dx cubed. And we're starting off by saying what is a. So a is simply equal to 3 to the power of 5, and that works out to be 343. So A has been done. Let's just go, yeah, done A. Now, secondly, it says, given that B is equal to 18D, and P is going to be less than 0, can we find the value of P? Can we find the value of C? Yeah, let's try and do those two. So B, part 1. They're telling me that B is equal to 18D. So here's B, and here is D, or a part of D when we're looking at those. So B is going to be 5C1, 3 to the 4, and my P. And D is going to be 18 lots of 5C3, 3 squared. And remember, this is p cubed, x cubed. I don't need the x part of it, but it'll be 3 squared p cubed there. Whoops. When we're looking at that. So let's tidy that up and see what that gives me. On the left-hand side, it's 405p. And on the right-hand side, if you do all that, that works out to be 18 multiplied by 90 p cubed. And then what we can do is divide out. So if we divide out, we can actually say, okay, p squared works out to be equal to, and it works out to be equal to a quarter here. Okay, so if we just divide out there, we get p squared equals a quarter, which means that p is the square root of a quarter, which is plus or minus a half. But remember, they said that p was less than 0, so actually p is equal to minus a half, not plus or minus a half. And then for the second part, we now want to work out what the value of C is, but remember, I now know what P is. So C is this part here. So what's that going to be? C is going to be 5c2, 3 cubed, p squared x squared, but just p squared as far as what we're concerned with, and we know that p is equal to a half, so 5c2, 3 squared, minus a half squared, not half, minus a half squared, and so again, if we calculate that, c works out to be equal to 135 over 2. So the standard sort of methods for binomial expansion, but written in a slightly different way in terms of working out all those constants, but not that different, and hopefully that all makes sense to everybody.